with the first session introducing the scene and setting the scene. And I welcome Antonio Navarro, the president of CMCC, to give a short speech and present CMCC.
Thank you very much. Good morning. Welcome, everybody. I understand I have 2 hours for this introduction. Is that correct? No, probably not. Well, welcome again. I'm the president, so my job is actually greet everybody and say, oh, how nice to see all you here. That, of course, is true, but I also would like to take the opportunity to remind everybody of the commitment that CMCC has towards this international cooperation program within the UN decade of the oceans. That is a very important part of our program of scientific innovation and technological development. So we're very happy to have this meeting here these days. I hope you have a very fruitful and useful meetings. And I also hope this will be the last in a long and fruitful collaboration of all of you. I feel that the kind of enterprise in which we are engaged really require cooperation at the global levels, and in some sense it's really a responsibility of the science community, that is the community that is more globalized and that kept links alive through various historical troubles, to keep these links functioning even when the world seems to go in a very different direction. So again, I think as a scientific community, we have a responsibility to keep this cooperation and sense of solidarity and collective responsibility together. So I'm very much forward to this meeting. I hope you enjoy it very much, and I hope you will forge fruitful scientific and personal relations during these 3 days. So have a great meeting.
Nadia. We switched my presentation with Nadia. Nadia will come later. And I will introduce you to our project, PredictOnTime. So just to set the scene and explain how we think to implement these activities. So PredictOnTime is a decade action, so it's one of the implementing project, and of course is connected to COSPREDICT together with the other 2 projects, CORIS and FLAME. So as Nadia will introduce later, COSPREDICT is our program, our reference program that will redefine the science of observing and predicting the global coastal ocean. And of course, we will develop infrastructure and capacity to offer all these data and capability to the worldwide coastal community. Our project itself is focusing on the short-term challenges, meaning the observing and predicting capability services and products for the global coastal ocean. So we want together to integrate observing system and forecasting system and test them in what we call pilot area sites that we will discuss tomorrow. One important concept is the relocatable. So once we have defined the optimal methodology and approach, we want also technologically being able to move this system, observing and forecast. So it's not only the modeling component, we want to be able to move and fast deploy the system where is needed. A few days ago, I had a discussion with the US Coast Guard. That's their main challenge today, to be able to deploy the system, a high resolution observing and forecasting system where is needed. Of course, for them it's not only coastal, but coastal, of course, is the highest challenge. So we want to do this activity with users and stakeholders because we want to be science-based, but not only science-driven. So we want to understand the need of the different aspects of the society, including pollution, extreme events. So we need to keep in mind that we need to interact with the stakeholder, and it's not straightforward. So we need to, I'd say, implement a co-design project approach and develop that with the users. The other challenge is that we are talking about more than 20 nations all over the ocean. So it's the coordination effort will be extremely important and challenging. But I'm sure that we will do it because we want to stay together and learn from each other. Our focus will be the natural extreme events, but not only them, also pollution and development of a sustainable blue economy, of a sustainable society. And I think if we can say a few words, we want to predict in due time, so to be useful for society, we need to increase the accuracy to get to an accuracy that is suitable for the application. And we don't want only to forecast and observe the variables, but we want to forecast and observe the impacts that the extreme events will have on the natural and human resources. And this is a challenge. So we want to, in the end, we want to minimize the impacts of it. So another important aspect that we have pointed out in our project is that we want to innovate the observing system. And one aspect you will see in these days is about community science or citizen science observing capacity. So we want to exploit these and develop instruments which are cost effective and easy to deploy. But of course, these apply also to the operational forecasting system that need to be usable by a wide community. And in the end, as you will see tomorrow in the last session, this observing and forecasting system should be demonstrated and used for what we call the application solution services like storm surge forecasting or oil spill observing and forecasting, so to be really useful for the society. We have already gathered a large partnership, but it's an open partnership. We are not talking about a funded project, so we are really open to include more partners. And I think today and in these days, that's the situation where we are able to enlarge our partnership. So please come to us, and you have already done in these days, and join the partnership. I will be very brief on the more specific objectives, but the main focus is to, as I don't want to repeat, but is to improve our observing and forecasting capacity in the coastal area, but also improve science of the coastal areas. Of course, we will contribute to the ocean decade objective of a predicted ocean. It's a predicted coastal ocean. And we want to build together an information system and methods that allow people to access the data. Anybody in the coastal area should be able to then use our products, your products, and data, and extract information from the data, as well as develop these end-to-end applications so that we really tackle the problems and solve some of the problems and some of our challenges. So I think I already expressed and explained the different aspects of improving the forecasting of the impact in the coastal areas and engaging the stakeholders. So then it will be also important to understand how to run our system, how to use and exploit HPC resources, how to share them in order to allow everybody to use models and access the data, as well as if you look to the objective 14 is to develop standard operational procedures to ensure interoperability on the key essential coastal variables. So this means that we need to agree also together on common format and common procedures so that we become a standard for the coastal observing and forecasting community. Just to tell you what we have done in the last year and this year, so we have started the project itself. We are enlarging the partnership. We are preparing the website. We have done the one on the workshop itself. We have established a good team dedicated to the project with Simon and Myred. Myred couldn't join today, but we are already 3 people, 2 of them totally dedicated to these coordination activities. And of course, we are also collaborating with other programs like the co-design Goose program, where we represent the exemplar on storm surge. So those are thematic projects. And I think we will further discuss today our pilot site and I'd say sub-projects. And then, of course, we need to search for funding together to implement them. So here we are. We have organized today workshop, and I think is the first step to really start the implementation of the project. Thank you.
So, good morning again, everybody. Sorry for this misplacement of the 2 talks, but there's also some time I gained. CostPredict is co-chaired by myself, Vili Curafalo, Joaquin Tintoré, and Emma Heslop from Goose. And today I would like to briefly overview for you the situation on Goose and the CostPredict. CostPredict is going to mainly impact the Goose after 2030, hopefully. And I would like also to briefly sketch the concept of the global coastal ocean that should emerge out of our experimental sites and out of our strategies, and some on the state of development of CostPredict. So Goose has 3 programs in the decade. One is dedicated particularly to the co-design of the observing system for thematic areas, and is the Ocean Observing Co-design is led by NOAA and University of La Sorbonne. And then CostPredict, which you know, and Observing Together, that tries to involve communities, local communities, in the decisions about the coastal observing and forecasting. So this is the, so we are specially dedicated to the coast. The concept of the global coastal ocean is a concept that was established already 13 years ago, or even more, through a series of volumes in the sea. And the concept is integrating land and ocean up to a certain point in order to capture all the relevant processes that occur in this area. So we extend inshore quite a bit more than it was actually foreseen in the initial stage, at the initial stage in 2010. We understand now that the sources of many problems in the sea come from the land. And so we understand that we need to include that part. How to include it? What is the portion of the land that we need to include? That's a scientific topic and requires some dedicated understanding and maybe discussion, which hopefully will be started, also using new data collected by the program. So the area extended then considers urban settlements, because urban settlements are, you know, part of the dynamic in the coastal area, and it extended to the offshore. So very briefly, the offshore. So why do I need the offshore? I mean, engineers have done this work starting 50 years ago. And what is the issue here? So the issue is that we need to include much more of the offshore than previously thought. So oceanography has to merge with the engineering community in the coastal area. And this is a challenge. Nomenclature is different. Way of working is different. And this is a challenge for CoastPredict. And I just want to show you an example why we need to go with the open ocean. This is a typical, I would say, small scale, advanced, very advanced coastal model, which goes inland. You can see it goes up the rivers in Georgia coast, the United States. That's the southeastern United States area. And here is an area where hurricanes arrive and they produce a storm surge. And the question is that domain enough? One. And second, is important what comes through the boundaries. Okay, so here we see the result of the model. The model is validated with the data, which also are essential. We do quite well, even though still some issues appear. And then here is the result of the analysis. The detided sea level is the black curve. You see the blue curve, which is the sea level only from offshore, without the local winds, without a hurricane arriving on the coast. And then you see the local hurricane winds adding 1/3 of the storm of the sea level. Now, this is not everywhere like this, right? So it depends. There are times where it is like this, other times. But if there is only one time it is like this, this is Hurricane Matthew. It destroyed part of the Georgia coast. If there is only one time, we have to take it. So we have to consider it, right? And we can. That's the point. Okay, so CoastPredict. So we need a new concept of the coastal area that goes as far offshore as needed, and we have to classify that. How much? Then you will hear also more on the climate scales, and there is another issue. Okay, so we need to define a predicted global coastal ocean from events to climate, to upgrade the oceanographic information infrastructure to hold so much data, to make them available so that people will construct their services on the basis of this data. We can't go everywhere and do for everybody everything, right? We have to make available, instruct people to use this new data, and then have many services being produced. And then co-design and implement a fully integrated coastal ocean observing and forecasting system. So we need observations that would, in addition to what observations do normally, really validate and calibrate our models the way the engineers have done, but now we have to do it in a monitoring way, which is, requires a lot of attention. So we have a technology gap. We don't have an integrated observing and modeling approach. You heard from Giovanni, we need to go inland, but we need to be relocatable. And there are, for example, no monitoring of salinity intrusions, right? Standards. What is the standard to monitor a salt wedge in a river? I don't think it exists. And maybe this is our job, right? To do it, to define it. Multi-sensor, we need to be, and also we need to have smart sensors, multi-model, ensemble, AI, you will hear a lot more, very important, open and free information to a certain degree, and then we have to allow people to customize the services and based on that information, even privately. Okay, so another concept is the urban ocean. There is a book which was written on urban oceanography, and you can see there the issues, but you can see also the opportunities, using the cities as monitoring sites for the coastal ocean. Much easier than going to a beach, which is non-populated. So we should use that concept. Okay, and okay, now to close, we have the challenge is large because we also want to answer the question: will the sea level rise in my area? And should we use a different tool? Should we use a different model, a different observing system? I don't think so. Too expensive. It's too expensive. Nobody can do that. So we have to have models and observing system, I should start. Observing system and models that can be used in both for both issues. And we can. So focus area 1 is on the short term, and this is PredictOnTime, main core project we call. Focus area 2 we'll hear soon from Joe Hopkins, and this is the main climate downscaling project for the coast. Focus area 3, it should look at the integration for maritime spatial planning, for integrated coastal areas. We don't have coastal management. We don't have yet a full proposal for that core, and I hope it will come out even from this meeting. We have coastal ocean and human health, and would be ocean health and human health issues at the coast. And we have the data management, very important interoperability core project, and we have to start to plan our equitable coastal ocean capacity. So these are the projects, and now we have a total of 3 core projects, plus I must say 7 affiliated projects. Remember now, 2, 5, 6. Okay, 6 affiliated projects, and through these projects where there is partial funding, there is in-kind, and so we need to focus on the big objectives. Okay, and these are all endorsed projects. So I conclude with this slide, even though I had 2 more because it's too late. So we would like to, in order to synthesize the information at the end, knowing what we can offer at the end of the decade, 2030 is very close. We need to start thinking already now what we want to deliver to the world along the coast, to our users and for the science. So we thought the best way is to organize a global coast experiment, which has many sites where people can apply equivalent methodologies to see how they work. So they become automatically relocatable by doing the comparison, and where we can try new technologies where is possible. I think it will be possible in many areas. And by that, we can, at the end of the decade, get a final statement on what is required to monitor the global coastal ocean. Okay, so we use selected coastal sites, which we hope to define with you partially. We are preparing also a survey. We are not ready completely for that. So we prepare a survey where we ask for demonstration sites, and where we ask you what you have, what you would like to have, and so on. And then out of that, we form groups in these 20 coastal areas across the ocean. And we discuss globally how to implement the new concepts, and at the end, extract a synthesis in 2027, 2028, if we are lucky. And so with this global coast experiment, I leave you to the other presenter that have very interesting information to give you. And I really look forward to the discussion in these days. It's very important to get your drive, your inputs, and your leadership in this field. We need to put all of us thinking together. Thank you.
Hi, thanks, Nadia. So I am Joe. I'm from the National Oceanography Centre in the UK, based in Liverpool. And I'm going to talk about the FLAME project that's part of Predict, and the steering team behind this are listed on this wall. So people here from CMCC, University of Alberta, and University of Calabria. So I want to give a brief overview of the motivations, kind of what we've done so far and where we want to go. Okay, so kind of motivational stuff. I think it's probably fair to say that climate change on a global scale is increasingly better understood and modelled, and thanks to efforts like CMIP, we're now able to plot multi-model means of global change in temperature and sea level rise, and we're able to put some uncertainty bounds around those things. But we recognise that those global responses are absolutely not globally uniform. And the impacts of change are felt most acutely on small, local, coastal scales where people live, where there's really high levels of uncertainty about what's going to happen. So whilst global projections are great, they don't do the local coastal zone, and there's a gap to be filled with downscaled modelling to really provide the climate change information that the communities need. So I plotted on here very roughly the number of regional downscaling studies, sort of climate focused, and I plotted them on LME so they're choosing something. So this is kind of what exists already at the moment. Notice that that isn't a linear scale on the right, and also notice that the bright reds and oranges and yellows are mostly focused Northern Hemisphere, around Europe, around North America. So there's a real lack of understanding and information available in the Southern Hemisphere, these kind of things. Okay, so what are the objectives of FLAME then? So by the end of the UN decade, we really want to have pushed forward and improved our decadal to centennial scale projections of change in coastal ocean. And notice that scale is quite different to what Giovanni was talking about with PredictOnTime. We want to be able to identify and recognize hotspots of change and the impacts that these things are going to have on coastal hazards, coastal ecosystems, the health of the environment. And we want to have provided and maybe step forward for the next generation of downscaling, predictive downscaling tools, bias correction techniques, hazard assessments that are actually going to be picked up and used by decision makers on the ground in local communities and used to make real decisions and make change. So the final objective, the really ambitious one, is to see whether we can actually create something that is starting to look like a global coastal ocean program. Obviously that exists for the global ocean, but there's no coastal ocean equivalent to what is kind of being done in the atmospheric world with Cordex. So we'd like to see whether we can take a step towards something that looks like that. Okay, I've only got 10 minutes, so I would suggest you just take a photograph of this and look in more detail at these priority activities that are laid out on the website. It's all about assessing performance of what we've got now, doing better in terms of process representation, downscaling techniques. As Nadia and Giovanni have both said, trying to make sure that these tools are relocatable, can be used by others. And I'm an observational oceanographer, so I really like this bottom left-hand point here. None of this can be done without having good observation. So you have to validate what your model is saying against what's happening in the real world. And that is the way to improve confidence in those models, and that's when people start to use them if they trust them. So this is not just a modeling project. That one little left-hand corner is important. Okay, I recognize I have 2 minutes. Okay, so we've made a start. So we held our first workshop in February of this year in Liverpool. So we had 60 people turn up, representing 36 different institutes, which was great. That was about 15 different countries. I've listed down on the left what the sort of session titles were. And one of the things we did a Slido poll, and we asked people that turned up what they actually did. The results are on the right. So we have collectively a bunch of people who are experts in model development, analysis, validation, observations. We're less strong on the community that really engages with capacity building, data management, science into policy. And I think that's a real challenge of the decade to get the inverse of that and marry them together. Okay, this is information that should be useful for tomorrow. So plotted on here in red are the countries represented by the people who came to Liverpool and gave talks and got involved. In yellow, I've plotted countries from where people wanted to attend. We wanted them to attend, but unfortunately they couldn't make it. So there's some scope to engage those people. And in the blue boxes, I have very roughly just put boxes around the areas that people talked about when we're doing climate projections for when they came to Liverpool, and added a few where I know we've got capability and that wasn't showcased. So that's kind of the regional reach of flame capability at the moment. Okay, so moving forward, Jason Holt, who's also not on the steering team, is taking the outputs from that meeting and he's preparing a paper around challenges of developing this consistent view of future climate change, future change in the coastal ocean. And we're in discussion about putting a special issue together off the back of those presentations. Anna Katavuta is building an early career network with a few other people, a few other ECOOPs involved in Coast Predict. And they have submitted a session for ocean sciences next year called Mind the Gap, Understanding and Predicting Future Coastal Ocean Climates. So watch out for that. And related to one of my other slides, we need to kind of fill in some of the gaps in our capability in a regional sense, bringing a few more people into the community. So much further down the line, we need to wrangle out what these common model experiments and protocols might be for some kind of NIP. There's a whole world of discussion around the complications of doing that. But we want to make sure we capture and share what we're doing. We want to make sure we capture and share model configurations and experiments as well. We are considering maybe applying for formal recognition as a MIP down the line. But if we do that, we want to make sure it is done in a way that doesn't create excessive barriers to people actually participating, because it's what we're talking about is starting to become very high PCC, relatively niche. We want everyone to be able to get engaged if they can. And the final point, learning to use the UN Decades network a little bit more to that client. So go to the website.
Thank you.
To get again my voice.
So Nadia will present us the UN Decade Coastal Resilient DCC, the Centralized Coordination Center. And then we get some questions if you have before the dolphin presentation.
So after planning the science and the technology, we thought that we needed to help these groups, further using one opportunity that the decade gave to us to organize around the decade collaborative centers. And these decade collaborative centers, using the endorsement, can get more resources for coordination. But in particular, this one is a decade collaborative center that look for interactions with stakeholders and helping your projects to try to interact with a large community of stakeholders. Just a highlight on what is the Ocean Decade now. The Ocean Decade has 45 programs, 214 projects, 69 contributions, which are different, slightly different, a big variety. And in general, lots of activities. The decade actions come from 42 countries in this, but most of these countries, unfortunately, are still in the Northern Hemisphere. And so we have, as a Decade Collaborative Center, we have the target to involve more from the Southern Hemisphere. It's a pretty good gender and diversity balanced action. In general, the decade, I'm very happy to tell you that. And they have, you know, a lot of goodwill to maintain that balance until the end. So the challenges, I just wanted to remind you, are 10. These are the famous decade challenges. And we are, with the Decade Collaborative Center, focusing on the increased community resilience to ocean hazards. So there are about, at this point, 14 centers, and there are 6 thematic ones that should be at the end 10, like there are 10 challenges, and then regional, some regional. How many regional, we still don't know, but we have, we should arrive at thematic coordination on a number of 10 approximately. So coastal resilience is there, but we have also, and we will hear later, ocean prediction at Mercator Ocean International. We have ocean data sharing at IOC, IODE. Forgot to say that some of these are not Decade Collaborative Centers, but are Decade Collaborative Offices, because they are already UNESCO organizations that formulate a center, and they get funding for the center. Okay, so 6 thematic. And our center in Bologna is working closely with the Decade Coordination Unit, which is the main coordination. And the Decade Collaborative Centers has 2 main drivers, scientific drivers: the program committee for the strategic management of the DCC, and the International Advisory Board, which hasn't been yet approved. Okay, so we are 6, no, actually 5, we have 6 coming, 5 people already, and hopefully soon you will meet our chief scientist, Andrea Valentini, and we have started with, you know, communication expert, program expert, and so on. So the program committee has been recently endorsed by UNESCO and is composed of a national committee, because of the funding is national, and an international one, which considers major decade actions representatives. And one of them is our course Predict through Joachim. So the strategic work plan, our DCCCR has the aim to promote the decade new science and technology with coastal stakeholders, implementing innovative co-design practices for coastal resilience. So the start point of this will be to do a lot of questionnaires, surveys, meeting with stakeholders, presenting your science and the science of the